Okay, so the video is going to focus today on analyzing a function basically at infinity. Let x get really, really large in the positive direction or really, really large in the negative direction. And when we start looking at limits at infinity, it's the behavior of our function as x goes to infinity or negative infinity. We want to associate this really with horizontal asymptotes. And that's how we viewed it last year in pre-calc. That when we look at the behavior of the function, is there any predictability to this function as you approach infinity or negative infinity? We can think about that, well, does the function have a horizontal asymptote? And so there should be a huge relationship that you see and understand between those two concepts. And so, limits at infinity, who wins? So if I look at a ratio, these rational functions, right, the ratio to see top or bottom winning, all I've got to do is look at the degree of the power, and say, okay, this function basically at infinity becomes like a quadratic. This function becomes a linear function. Well, quadratic trumps linear. The numerator will be increasing more quickly than the denominator. If the top wins, then I know this number is either getting exceptionally large, or if you're going to negative infinity, exceptionally small in the negative direction, or large numbers in the negative direction. And so its limit would either be positive infinity or negative infinity. And so here, if a rational function, the highest degree is greater, then the limit as x approaches infinity, depending on which, if it's positive or negative, will be either positive infinity or negative infinity. Okay? Now, if the bottom wins, if your numerator's not increasing as quickly as your denominator, that means overall, if your denominator is getting bigger, you're becoming a fraction that's getting smaller and smaller and smaller and smaller and smaller and smaller until you get close to zero. So when the bottom wins, there's a horizontal asymptote at zero, and therefore the limit would equal zero. And then when it's probably the most interesting to analyze is when it's a tie. And the idea is, if you go off to infinity, subtracting 8 is negligible. I'm not going to notice it. So this really is going to behave like 3x over x, or the constant value of 3. So we know that this is going to have a horizontal asymptote at y equals 3. Therefore, its limit value as you approach infinity would equal 3. And so then if there is a tie, and that's this last case, right? If the highest degree of the numerator is equal to the denominator, then your limit as x approaches infinity would be the ratio of a to b, where a, there it is, and b are the lead coefficients of your function. Lead coefficients, leading terms, when put in order from the highest degree down to the lowest degree. Okay, so our job then is to take a look at rational functions and to decide, comparing who wins. Like, for example, and I think all these are either approaching infinity or negative infinity. So as you approach infinity, bottom wins, it goes to 0. As you approach negative infinity, so I have a ratio here. It's a 1-to-1 ratio. And so this is going to behave like negative 1x over x. So this would behave like negative x over x, which is equal to negative 1. So we know its limit value is equal to negative 1. And it didn't really matter that we're approaching negative infinity. I guess technically I should have written x over negative x, since that flips the sign, but it's still going to give you a ratio of negative 1. Okay, here I do have to be careful. I'm approaching positive infinity. This thing's going to behave like 3x cubed over 2x squared, and that's going to behave like a 3x over 2. So as x goes to infinity, this just goes to infinity 1.5 times faster, but it's still going to give you a limit that's equal to infinity. And kind of thinking about it this way, where you kind of ignore the terms that aren't the highest power, really is a smart thing to do, because those are the things that take control. In the numerator, what takes control is really this negative 2x to the 4th. The denominator, what takes control is 8x cubed. So you identify those highest powers, And then what can you simplify? That's like negative 1x over 4 if I reduce that. And so as x goes to infinity, this is going to go slowly to negative infinity, or I guess more slowly because it's the negative 1/4 as the coefficient, but it's still, it's going to equal negative infinity as a limit value, because as you approach infinity, you still carry on this negative. Okay, so let's see, number 5, this is, again, a linear function over linear approaching infinity. It's a 1:6 ratio, so this would be negative 1/6. A little simplifying, the numerator is going to, if I were to expand that out, it's going to behave like 8x cubed. That would be your lead coefficient. This is 4x cubed, your lead coefficient. That's a 8 to 4 ratio is 2. So this would be a value of 2. Number 7 and 8, when you start involving square roots, so you have to realize that whatever takes control here is still under the influence of that square root. And so the numerator is going to behave like the square root of 4x squared. The denominator will keep that x. And so as you're approaching infinity, those are positive values. So I know this overall thing is positive. When I root it, I don't have to worry about the plus or minus. But now realize that even though deceivingly that's quadratic, a quadratic under the influence of a square root actually behaves like a linear function. This is going to be like a 2x over x, which is a ratio of 2. So its limit value would equal 2. And then here, again, my numerator is behaving like a negative 3x. So I use my approximation sign. And this is going to behave like an x. This is actually going to behave like the square root of x squared, which is x. I don't have to invoke the plus minus because we have positive numbers only. And therefore, that's a negative 3x over 2x, so it's a negative 3 to 2 ratio. So again, I hope this might seem a little familiar, at least when I know when I teach honors pre-calc, I really kind of talk about like basically limits. So this should look familiar to you. And then the next video we'll talk about what if your function has 2 horizontal asymptotes, which is not, I don't think, taught in pre-calc.